Hello, madam. Any problem? Madam, shall I start the session?
Yes, sir, you can.
Okay, madam. Thank you. Thank
నేను
you.
అప్పుడే రికార్డింగ్ స్టార్ట్ చేసేసాను. Yes.
Okay, madam. Okay, madam. Good afternoon to all. Already we have completed three modules. That is signal classification, properties of signals, and how to represent various types of signals. And coming to properties of systems also, system definition, classification, properties of systems, and how to check the system for causality, stability, linearity, that is linear shift invariant systems. We have completed all those things. In this module, we will see Fourier transform and sampling theorem. It is another important topic in signals and systems. First of all, transformation. What is transformation? Transformations are mathematical tools which are used to convert from one type of domain into another type of domain. In our real time, everywhere we are using time domain analysis. Time domain analysis. Right now, I am taking class. This class is scheduled from 2:30 to 4:30. That is time only. With respect to time only, we are doing something. Outside temperature varies with respect to time only. We are getting power supply from outside line with respect to time only. We are getting signals through our mobile phone. Call it as electromagnetic wave. That is also a function of time and space coordinates. Means everywhere information may changes or varies with respect to independent variable, that is time. But coming to communication, in communication, we will discuss about frequency, like listening, like music, FM channels. We are getting FM channels like at 99.9 megahertz or 102.2 megahertz, like that. And in communication, we are sending so many things and receiving the things for perfect or distortionless communication, where output information is exactly equal to input. If something is wrong in the communication, then output may be distorted. Then what is our role? What is engineer's role? We need to evaluate, we need to analyze what happens in the communication system, where it happened, how to rectify all those things. For that, we need both time domain and frequency domain analysis. Time domain analysis is required and frequency domain analysis also required. That's why we need some conversions. We need some converters, those like mathematical tools required to convert a known time domain representation into frequency domain representation. For that, there are so many types of transformations. Among them, popular method, popular process is Fourier transform. Fourier transform is applicable for both continuous time and discrete time signals. Fourier transform is used for both continuous time and discrete time signals. Whatever Fourier transform is used for continuous time signal is called simply Fourier transform. Simply Fourier transform, sometimes call it as continuous time Fourier transform. And whatever transformation used for discrete time signals is called discrete time Fourier transform, DTFT. DTFT. In both the transformations, complexity is more. Complexity is more in both the transformations. To reduce that, always you can go for Laplace transform and Z transform. Those are simple procedures, simple methods which are used to evaluate frequency domain functions. Laplace transform is used only for continuous time signals. Z transform is used only for discrete time signals. discrete time signals. After that, we will see fast Fourier transform. For that, discrete Fourier transform, then fast Fourier transform. All these transformations are included in our subject, signals and systems. And another topic here is sampling theorem. Sampling process or sampling theorem. Nowadays, everywhere systems are digitalized. Digitalized means only we can process digital signals through digital systems. We cannot process analog data like my lecture. My lecture is a continuous time information or analog data, analog signal. We cannot process straightforward analog data through a digital system and communication. That's why initially we need to discretize my continuous time data or analog data. Discretize means we need to convert this continuous time signal into a discrete time signal. Discrete time signal. For that, sampling theorem is used. Sampling theorem is used to convert given continuous time signal into discrete time signal. We will see how to apply sampling theorem and how to solve problems, different types of problems. Here, this module includes different topics like representation of aperiodic signals by Fourier transform. Mainly, Fourier transform is used for aperiodic signals as well as periodic also. We'll see separately how to represent aperiodic signals by Fourier transform. Then convergence of Fourier transform. What are the restrictions for a signal to evaluate Fourier transform? Fourier transform, we cannot apply Fourier transform to every signal. Every signal, not possible to apply for every signal. Those signals must satisfy some restrictions. Those signals must satisfy some restrictions. Those restrictions or conditions are called Dirichlet conditions. Dirichlet conditions call it as convergence of Fourier transform. Then another important thing, properties of Fourier transform. All the properties are very important to solve problems in stipulated time. We have to apply various properties like linear property, time shifting property, frequency shifting, time reversal, conjugation or conjugate symmetry, time and frequency scaling, both are same, time scaling or frequency scaling property. Then differentiation in time domain, differentiation integration, integration in time domain, differentiation frequency domain, integration frequency domain. Then duality property, then Parseval's relation used for aperiodic signals, then time convolution theorem, finally frequency convolution theorem. These are the various properties comes under Fourier transform. Next, in topic number 4, we'll see Fourier transform of various classes of signal. What are different classes of signals? We know like impulse signal, signal, rising, decay. There are many types of predefined and well-defined signals. For all those signals, our task is to evaluate Fourier transform. We will see in 4th topic. And Fourier transform of periodic signals. This is another thing. Actually, Fourier transform is used for aperiodic signals. For periodic signals, we can use Fourier series. But Fourier transform is also used for periodic signals. We will see how to use Fourier transform to evaluate frequency domain of a periodic signal. Finally, we'll see sampling theorem, how to apply sampling theorem to convert given continuous time into a discrete time, and analysis of samples in frequency domain. We'll see all these things in this module. First topic is the representation of aperiodic signals by Fourier transform. Already is used to obtain the frequency domain representation of a given continuous time domain aperiodic signal. For aperiodic signal, you can apply Fourier transform to get frequency domain representation. Mathematically, it is defined like this: Fourier transform of a periodic signal. It is omega, x of omega. Both are same. Actually, frequency domain may be represented with x of omega or x of j omega, because in general frequency domains are in complex form. Complex. For real time also, most of the signals are real time only. Real time signals. But frequency domain of those real time signals are in the form of complex frequency domain, that is x of j omega. Sometimes that may be represented with x of omega also, no problem. Okay, don't equate these two and don't equate j omega is equal to j like that. Okay, that is just notation or representation. Mathematically, it can be computed from the formula. integral minus infinity to plus infinity x of t e power minus j omega t. We have to know the basic formula which is used to compute Fourier transform. And this is in terms of omega. Omega is frequency, where omega is equal to 2 pi f. We can represent frequency domain in terms of f also. F domain or frequency domain. Same formula, Fourier transform x of t. It is represented with x of j 2 pi f. Omega is equal to 2 pi f. That is equal to simply x of f. No need to write 2 pi f again here, because this is frequency domain. Just x of f, that is enough. X of f. Same formula, instead of omega put 2 pi f, 2 pi f into t dt. That's all. We can use first formula or second formula. And similarly, reverse procedure is also there. Reverse means if we know frequency domain, then you can obtain time domain by using inverse Fourier transform. In inverse Fourier transform, we have to use 1 by 2 pi. 1 by 2 pi integral minus infinity to plus infinity x of omega e power j omega t d omega. This is equal to integral minus infinity to plus infinity x of f e power j 2 pi f t dt. There are two formulas here. In terms of omega, if we use in terms of omega, then use 1 by 2 pi. 1 by, this is important thing. If we use frequency domain, simply f domain, then no need to use 1 by 2 pi, because here it is d omega, integration with respect to omega, that is d omega. If omega is equal to 2 pi f, then d omega is equal to 2 pi into df. Here we will get 2 pi, actually 2 into pi, 2 pi by 1 by 2 pi gets cancelled, 2 pi gets cancelled. Therefore, if it is defined in f domain, no need to use 1 by 2 pi. Okay, this is the formula used to evaluate time domain signal. Time domain signal x of t, where the frequency omega is measured in radians per second and f is measured in hertz. F is measured in hertz and omega is measured in radians per second, where x of t and x of omega are Fourier transformable pairs. Fourier transformable pairs. By using Fourier transform, we can convert x of t into x of omega, and by using inverse Fourier transform, we can convert from x of omega to x of t. That is the meaning of Fourier transformable pairs. In general, the frequency domain x of omega. In general, the frequency domain x of omega may be complex. Most of the times, frequency domains are complex form, and graphical representation is not possible. That's why we can go for magnitude spectrum and phase spectrum. Spectrum is Latin word which is used for image representation. That image may be in the form of magnitude value, or phase, that is angle. Magnitude is amplitude, and it is phase angle. And complex things are represented like this. X of omega is equal to real part plus j into imaginary part, where xr of omega is real part of x of omega, xi of omega is nothing but imaginary part of x of omega. And magnitude spectrum can be computed from this formula. Modulus of x of omega is equal to root of real part. This is the formula used to calculate magnitude. After getting this magnitude, then go for graphical representation. Represent magnitude with respect to frequency is called magnitude spectrum. Magnitude spectrum is the graphical form which is drawn between modulus of x of omega and omega. Then phase angle. How to calculate phase? Tan inverse of imaginary part by real part. Tan inverse of imaginary part by real part, that is angle of x of omega is equal to tan inverse of xi of omega by xr of omega. That is imaginary part xi, xr is real part. Okay, this is the theory behind Fourier transform, evaluation of Fourier transform, evaluation of inverse Fourier transform, then magnitude spectrum and phase spectrum. We have to know all these basic concepts. Then second topic is convergence of Fourier transform. Fourier transform means, already told you, we need to compute frequency domain representation of a given continuous time domain signal. there are infinite number of continuous time domain signals. For every continuous time domain signal, we can get Fourier transform? No. No, there is a restriction. There is a restriction. That restriction is x of t must satisfy some restrictions, some every signal, every continuous time domain signal must satisfy condition 1, condition 2, condition 3. What are those conditions? Those conditions are Dirichlet conditions, name of scientist, Dirichlet conditions, and those conditions are like this. Given signal x of t is absolutely integrable. Absolutely integrable. See, this modulus of x of t dt integrate over wide range of time. That should be finite. That should be finite. Okay, that is first property. Every signal must be absolutely integrable. Absolutely integrable. Sometimes not possible to evaluate the integration of a particular thing. Then how to evaluate Fourier transform? No, not possible to evaluate Fourier transform. And this is nothing but like some area under that signal, magnitude, modulus. That should be finite, less than infinity. Okay. And second condition, in any finite interval of time, the signal x of t have only finite number of discontinuities. Furthermore, each of these discontinuity must be finite. Meaning of this is, if we know the waveform, evaluate limits like rectangular signal. Suppose we'll see one example. See here. See here at t is equal to t by 2. At t is equal to t by 2, what is the amplitude of the signal? What is the amplitude of the signal? That is my question. At t is equal to t by 2. At t is equal to t by 2, right limit is 0. See, right limit is 0. Left limit is a. A is the left limit value. 0 is the right limit value. It means this signal amplitude cannot be computed, or not possible to compute at t is equal to t by 2. That's why this signal is discontinuous at t is equal to t by 2. Similarly, at t is equal to minus t by 2, right limit is a, left limit is 0. Therefore, this function or this signal has two discontinuities. One is at t is equal to minus t by 2. Another one is t is equal to t by 2. Totally, this signal consists of how many discontinuities? Two discontinuities. Like that here, second condition or second restriction is, in any finite interval of time, take some finite interval, maybe 0 to 2 pi r, minus 100 to plus 100, whatever finite interval of time, count number of discontinuities in the signal. Number of discontinuities in the signal. Those discontinuities are infinity. If number of discontinuities are infinity, then it is very difficult to get Fourier transform. Not possible to evaluate Fourier transform. This is another restriction. In any finite interval of time, the signal x of t have only finite number of discontinuities. Finite number of discontinuities. Furthermore, each of the discontinuity must be finite. Sometimes the discontinuity values may be infinity. Sometimes amplitude may be infinity. Cannot be. Amplitude of that discontinuity is always finite. Then third condition, in any finite interval of time, the signal x of t have finite number of maxima and minima value. Every function must have some maximum values and minimum values. Every function. Those maxima and minima values must be finite, cannot be infinity. In any finite interval of time, the signal x of t have finite number of maxima and minima. One condition is absolutely integrable. You have to know these restrictions before computing Fourier transform. That signal must be absolutely integrable. Second condition is, in finite interval of time, the signal have finite number of discontinuities. Furthermore, each of the discontinuity must be finite. In any finite interval of time, the signal x of t have only finite number of maxima and minima values. finite number of maxima. And these are the restrictions comes under the existence of Fourier transform. Now we'll see basic problems. This is a fundamental problem and is a formula. Determine the Fourier transform of impulse signal del of t. First, we have to know the procedure. Next thing is we have to know the formulas. To solve problems, to complete this solution in a stipulated time, we have to know the formulas, as well as we have to know the procedure also, because basic things or fundamental things are very important, very important. If we know the basics, then we can do anything. Without knowing basics, like shortcut methods, no use of learning shortcut methods without knowing basic things. First, we have to know the process of solving problem in general method. Then we will see shortcut way. Okay, here. Fourier transform of delta of t. This is the formula used to evaluate Fourier transform of Fourier transform of del of t is equal to integral minus infinity to plus infinity del of t e power minus j omega t dt. Unit impulse signal del of t is defined at t is equal to 0 only. At t is equal to 0. If t not equal to 0, del of t is 0. If t is 0, what happens? It will become e to the power of 0. E power 0, 1. 1. Remaining part is integral minus infinity to plus infinity del of t into e power 0. That is simply del of t because of it is 1. This part is, that is 1 simply. That is 1 simply. Therefore, it is del of t. You know, area, this knows it is equal to area under impulse signal. Area under any impulse signal is 1. That is the property. Area under any impulse or unit sample signal del of t is 1. Therefore, this integral is equal to 1. Fourier transform del of t is equal to x of omega is equal to 1. This is the procedure actually, and now this is the formula. You have to know this formula. Fourier transform of del of t, simply put 1. Simply put 1. Fourier transform of del of t is equal to x of omega is equal to 1. How to represent graphically? 1. 1 means what? Constant function. 1 means constant function. Constant functions are extending from minus infinity to plus infinity, constant. Whatever value, we hear 1. 1 is the amplitude, that 1 is constant amplitude between minus infinity and plus infinity. This constant is also known as DC signal. DC signal. Therefore, see this note, impulse signal and DC signals are Fourier transformable pairs. We have to know this line. This is important statement. In competitive examination, they will use some options which are the following are Fourier transformable pairs like that. Here, impulse signal and DC signals are Fourier transformable pairs. Meaning of this is Fourier transform of impulse is DC and inverse Fourier transform of DC is impulse. That's why impulse and DC signals are Fourier transformable pairs. Coming to second problem. Determine the Fourier transform of decaying exponential signal. Decaying x of t is equal to e power minus at u of t. Here, if t value increases, u of t shows right side. U of t shows right side. This is right side signal extending from t is equal to 0 to infinity. If t is equal to 0, e power 0, 1. 1 is the maximum amplitude. And if t increases, amplitude decreases because after long time t is equal to infinity, amplitude becomes e to the power of minus infinity 0. Its amplitude decreases when time increases. That's why it is a decaying exponential signal. Now our task is to calculate the Fourier transform of that. Here A is positive. If A is negative, it becomes unbounded. Now see the definition of Fourier transform. We have to know the Fourier transform formula and substitute there. Fourier transform of e power minus at u of t, integral this, substitute here, e power minus j omega t dt. Here u of t. U of t is 1 when t is positive. U of t is 1 when t is positive. Simply substitute and it is 0 to infinity because u of t is extending from 0 to infinity for with one amplitude. 1 into anything is same thing. Therefore, it is e power minus at, e power minus j omega t, take minus common, a plus j omega into t dt. Integration of e power x. E power x only, e power minus of same thing divided by coefficient of t. Coefficient of t. Substitute upper and lower limits from 0 to infinity. Substitute t is equal to infinity first. E power minus infinity minus e power 0 divided by minus of a plus j omega. Numerator e power minus infinity 0 minus e power 0 1 0 minus 1 by minus of a plus j omega. That is 1 by a plus j omega. This is the procedure actually. We have to know this formula in examination to solve questions. If we know this formula straightforward, we can finish the problem. Okay. See, Fourier transform, decaying exponential signal. This is real signal. This is a real time. This is a real signal, not complex. But in frequency domain, we got complex form. 1 by a plus j omega. Already told you in frequency domain. In frequency domain, almost all frequency domains are complex form. Complex consists of real part and imaginary part. What we have to do? Evaluate magnitude spectrum and phase spectrum separately. Now magnitude spectrum is modulus of x of omega. Modulus magnitude a plus ab, root of a square plus b square. Root of a square plus omega square is magnitude spectrum. Coming to graphical representation, it is symmetrical about y-axis. It is symmetrical about y-axis. In examination, they will ask some like magnitude spectrum is symmetrical about y-axis, a bit. Phase spectrum is odd function like that. Okay, we have to know this result. Based on this result, we can get magnitude and phase separated. Then we can go for analysis, whether it is even function or odd function or antisymmetric or odd symmetry like that. Okay, see, modulus of x of omega. Put omega is equal to 0. At omega is equal to 0, 1 by a. 1 by a is the amplitude occurs at omega is equal to 0. After that, if omega increases, see, if omega increases, 1 by increases, decreases non-linearly, and after a long time, if omega is equal to infinity, 1 by infinity, 0. 0 amplitude after a long time, and initially at omega is equal to minus infinity, 1 by minus infinity whole square, again 0. Initially 0, increasing, and 1 by a is the maximum amplitude, after that decreasing. This is the magnitude spectrum of given decaying exponential signal frequency domain representation, and its maximum amplitude is 1 by a, which occurs at horizon. Next, coming to phase. How to calculate phase? Tan inverse of imaginary part by real part is the formula. Tan inverse of imaginary part by real part. See, numerator. In numerator, it is simply 1. Numerator is simply 1. 1 means 1 plus j0 actually, like this. 1 plus j0. 1 plus j0 means its phase is tan inverse of 0 by 1. Tan inverse of 0 by 1 is tan inverse of 0, that is 0. Numerator triangle is 0. Denominator triangle is tan inverse of omega by a. For a division, take the difference. Take the difference. Angle of numerator minus angle of denominator. That is the formula. Phase spectrum. Angle of numerator 0 minus angle of denominator tan inverse of omega by a. Now see this function. Minus tan inverse of omega by a. See, at omega is equal to 0. We have to know the graphical form, how to get. See, if omega is equal to 0, tan inverse of 0, 0, 0. Suppose if omega is equal to tan inverse of omega is equal to large value, infinity, let us assume, very, very high. Omega is very high. If omega is infinity, tan inverse of infinity by a. That is tan inverse of infinity. Tan inverse of infinity. Tan inverse of infinity is 90 degrees. 90 degrees, but minus sign is there, minus 90. Means minus 90 degree is the minimum angle of this phase spectrum. Minus 90 degrees is minimum. And we take negative locations. Negative, like minus omega is equal to minus 1, minus 2, minus, like the negative locations. After long time, it will become minus infinity. That is minus tan inverse of infinity. That is plus tan inverse of infinity. Plus tan inverse of infinity is 90 degrees. Means 90 degrees is the maximum angle. 90 degrees is maximum angle which occurs at omega is equal to minus infinity. Minus 90 is the minimum angle which occurs at omega is equal to infinity. The spectrum is even symmetrical about y-axis. This is anti-symmetrical about y-axis. This is anti-symmetrical about y-axis. Next problem. Determine the Fourier transform of rising exponential. These are the basic signals or fundamental signals. Impulse signal, rising exponential, decaying exponential, double exponential, like that. This is rising, e power at u of minus t. This is left-sided rising, left-sided exponential signal. Why left side? Because of u of minus t. U of minus t is 1 when t is less than 0. U of minus t is 1 when t is less than 0, left side. It is left side signal and is rising exponential where amplitude rises when time increases. Okay, now from the definition, every time we have to use Fourier transform formula for basic functions. Fourier transform of e power at u of minus t. U of minus t is 1 when t is negative, means minus infinity to 0. We need to consider minus infinity to 0, where the function is e power at and e power minus j omega t. Take the product of these two, e power a minus j omega into t dt. Okay, now integrate it. Integration of e power x by coefficient of t. Substitute upper and lower limits. T is equal to 0, e power 0 1 minus e power minus infinity 0, that is 1 minus 0 by a minus j omega, that is 1 by a minus j omega. We have seen frequency domain of right side signal is 1 by a plus j omega. Fourier transform of left side e power at u of minus t. Left side signal is 1 by a minus j omega. This is the procedure. By using this procedure, we can calculate, we can evaluate the frequency domain of any type of signal. Any type of signal, irrespective of signal, you can evaluate the Fourier transform. Now, once again, see, it is complex form. Every complex domain can be represented as real part plus imaginary part, and evaluate its magnitude spectrum by taking modulus of x of omega is equal to 1 by root of a square plus minus omega whole square, that is omega square only. Means magnitude spectrum of right-sided signal or left-sided signal, causal signal or anti-causal signal. For both signals, signal is different actually. Right side is nothing but decaying exponential. Left side nothing but rising exponential. Signals are completely different, but magnitude spectrums are same. Magnitude spectrum for previous signal also 1 by root of a square plus omega square. Now see here also same thing. Magnitude spectrum is common for both rising and decaying exponential. Same spectrum, no change in the spectrum. Coming to phase angle, same procedure. Numerator is constant, that is real part, real 1 plus j0, angle tan inverse of 0 is 0. Numerator is 0 minus denominator minus tan inverse of minus omega by a. 0 minus tan inverse of minus omega by a. Minus of minus becomes plus. That's why it is tan inverse of omega by a. Here difference is previous spectrum. See the difference between previous spectrum and this spectrum. This is previous spectrum minus tan inverse. It is plus tan. That's all. Left becomes right, right becomes left. That's all. Right side. If omega is infinity, then amplitude is pi by 2. Right side positive angle, left side negative angle. Previously left side positive angle, right side negative angle because of minus. This is also anti-symmetrical about y-axis. Only magnitude spectrum is even, symmetrical about y-axis. But now phase spectrum is not even, not symmetrical about y-axis. Now see another example. Determine the Fourier transform of double exponential signal. Double means it is the combination. It is the combination of rising exponential and decaying exponential, and it is represented with e to the power of minus a modulus of t. E power minus a modulus of t. See the Fourier transform definition and substitute e power minus a t at x of t. Here e power minus a modulus of t. Modulus of t is plus t when t is positive, minus t when t is negative. Minus t when t is negative, plus t when t is positive. Like that, separate the integration and do just it is the sum of previous two problems. Double exponential is nothing but sum of rising exponential and decaying exponential. Just add those two. It is simple, normal simply just previous derivation only. Just okay. Here sum of these two. What 1 by a minus j omega. This is a previous answer. This is before that. This is the answer for decaying exponential. This is the answer for rising exponential. It is the problem. This problem is exactly equal to sum of previous two problems. No need to do all these things in competitive examination. We have to know this formula. Just it is the sum of decaying exponential and rising exponential. Sum of these two, take LCM, a minus j omega into a plus j omega. A square minus of j omega whole square. That is a square plus omega square. Numerator, see, addition, a plus j omega, a minus j omega, 2a. 2a by a square plus omega square. We have to know the procedure and we have to know the answer also. We have to know this answer. Fourier transform, we know Fourier transform of decaying exponential, 1 by a plus j omega, rising exponential, 1 by a minus j omega, double exponential, 2a by a square plus omega square. We have to know all the three. These are the basic things actually. Okay. In examination, don't do all calculations. We have to know these formulas. Fourier transform of this. 2a by a square plus omega square. Substitute omega is equal to 0. What happens? If omega is 0, 2a by a square. That is 2 by a. 2 by a is the amplitude occurs at origin. After that, if omega increases, amplitude decreases goes on. Similarly, left hand side also decreases. Magnitude spectrum is again even, but not same exactly. Previous function is different. Magnitude spectrum is different, but shape is similar. 1 by root of a square plus omega square. Previous function. Now no root, and in denominator it is 2a. 2a by a square plus omega square. And this function is, see, this function is pure real, not complex. Therefore, no need to go for magnitude spectrum and phase. This is only magnitude spectrum. This is only original frequency domain. Original frequency or magnitude both are same in the case of double exponential signal. That's all. No need to go for phase because this is real. Okay. Next one is determine the Fourier transform of a signal. Limit a tends to 0, e power minus a modulus of t, sgn of t. Here, sgn of t is signum signal. Signum signal is multiplied with double exponential. Previous example, e power minus a modulus of t is multiplied with sgn of t. What is sgn of t? Sgn of t amplitude is 1 when t is positive, minus 1 when t is negative. It's a double step signal. SGN of a signal is a double step signal. It consists of two steps. One is positive step, another one is negative step. It consists of u of t and the u of minus t. Combination of u of t and u of minus t is called signal, SGN of t. It is multiplied with e power minus a modulus of t, where limit a tends to 0. Just substitute in the mathematical form, integrate it, and here limit a tends to 0. Don't substitute a equal to 0 initially. At the end we will see. Now take the product of these two, sgn of t into e power minus a modulus of t. Sgn of t value minus 1 when t is negative, plus 1 when t is positive. Simply minus 1 plus 1, same thing. Minus of this part plus. Just it is similar to previous derivation, no change. Just it is a double exponential signal. Same thing, 1 by a minus j omega, 1 plus j, a plus j omega. Because of sgn of t, see here we got minus sign because of sgn of t. In previous case it is plus. That's all. That is only difference between these two. Okay. Now it is limit a tends to 0. Put a equal to 0 here, what happens? If a is 0, minus j omega, minus into minus plus 1 by j omega. Here 1 by j omega, 1 by j omega plus 1 by j omega, 2 by. It is the frequency domain of Fourier transform of limit a tends to 0 e power minus a modulus of t sgn of t. Now see, it is a normal thing, simple thing. Limit a tends to 0. Substitute a is equal to 0. What happens here? E power 0. E power 0, 1. This total part becomes 1. If it is 1, then it is simply a Fourier transform of sgn of t. Fourier transform of sgn of t. What is that? 2 by j omega. By heart this formula. Fourier transform of signal is 2 by j omega. Further, this is the procedure. Extension process of double exponential signal. In examination, no need to write all the steps. Just for your reference only, I am telling how to solve questions. But in examination, we have to know this answer. If the question is appeared like Fourier transform, multiple choice question like Fourier transform of sgn of t, pick this answer without solving. Not only this, double exponential, rising exponential, decaying exponential. We have to know these are the fundamental things, fundamental formulas. Based on these formulas, we can solve, like we can apply some properties, and we can do it within stipulated time by using properties. Now, magnitude spectrum. This is imaginary. Not possible to draw the graphical form. That is spectrum, not possible. That's why I go for magnitude, spectrum, and phase spectrum separately. Okay, this is magnitude. Magnitude modulus of this is equal to modulus. That is 2 by omega. 2 by omega, simply modulus. Modulus 2 by omega. If omega is equal to 0, what happens? 2 by 0 infinity. Means at horizon, its amplitude is infinity, very large amplitude at horizon. After that, if omega increases, goes on. Omega, 2 by increases. 2 by increases means decreases. Goes on amplitude. After a long time, if omega is equal to infinity, 2 by infinity, that is 0. 0 means after a long time, amplitude becomes 0. Similarly, left, it is even actually. Modulus of 2 by omega is an even function. Even functions are symmetrical about y-axis. That's the end of sgn of t. Now, another important question is rectangular signal. Determine the Fourier transform of a rectangular signal. Rectangular signal is defined like this: a rectangular t by capital T. It shows its amplitude is capital A between minus t by 2 to plus t by 2. In between minus t by 2 and plus t by 2, the duration is capital T. Here capital T shows duration of the rectangle, capital A shows height of the rectangle. Height of the rectangle, duration of the rectangle. Now for this rectangular signal, what is the Fourier transform? This is another important thing. Finally, we will conclude rectangular signal and sinc signals are Fourier transformable pairs. Rectangular signal and sinc signals are Fourier transformable pairs. Now see, from the definition of Fourier transform, see the basic formula. It is the starting step of every problem. Frequency domain can be computed from the basic definition of Fourier transform. All fundamental things, not complicated problems. Lengthy problems, we can apply properties and we can minimize it. Okay, A rectangular T by T. Integral minus infinity to plus infinity, A rectangular T by T, e power minus j omega dt. Rectangular function definition, its amplitude is capital A between minus t by 2 and plus t by 2. See, minus t by 2 and plus t by 2, its amplitude is capital A into remaining thing e power minus j omega t dt. Now integrate it. A into integration of e power minus j omega t by coefficient of t, that is minus j omega. Substitute upper limit and lower limit. Very simple thing. E power minus j omega t by 2 minus e power j omega t by 2. It is of the form e power j theta minus e power, take minus common, e power j theta minus e power minus j theta. E power j theta minus e power minus j theta by j omega. J omega. Numerator is e power j theta minus e power minus j theta is 2j sin theta. 2j sin theta, or sin theta is equal to e power j theta minus e power minus j theta by 2. J gets cancelled and amplitude becomes 2a by omega into sin function, sin of omega t by 2. This is the answer. Now convert this into sampling and sinc functions. 2a by omega into sin omega t by 2. Sin omega t by 2 by, for convenience, take it as omega t by 2. Omega t by 2. Here t gets cancelled. Result becomes 2a by omega only. Instead of writing 2a by omega, I have taken like this. At into omega t by 2. Both are same. Now it is of the form sin t by t. Sin theta by theta. Sin t by t or sin theta. Sin theta by theta is equal to sampling theta. This is the formula, call it as sampling signal. Sinc or sampling signal. Two different ways of representation. Sinc or sampling. Therefore, this ratio is called sampling omega t by 2. Amplitude 80 sampling. Next, convert this into sinc also. You can represent this function in terms of sampling, in terms of sinc. How to get sinc? Sinc function is defined in F domain. Sampling function is defined in omega domain. Omega is the frequency in sampling. Okay? Now see here, 2a by omega, 2 pi f sin omega, 2 pi f t by 2. See, 2a by 2 pi f. 2 gets cancelled. A by pi f. A by pi f. Next, come here. Sin pi f t by 2. 2 pi f. 2 to get pi f t. Sin pi f t. Now again conversion. Something. Sin pi f t. Sin pi f t by pi f t. There is a formula. Sin pi t by pi t. Sin pi t by pi t is equal to sinc t. Sinc function definition. Sin pi t by pi t. Now pi f t by pi f t is equal to sinc f t. Remaining part. See, at here pi f t. At pi f t. T gets cancelled. A by pi f. Yes, it is a by pi f only. Instead of a by pi f, we have taken like this. At by pi f t. multiply numerator denominator with capital T for our convenience. Now, AT is the amplitude. AT is the amplitude. It occurs. See, AT is the amplitude of sync signal. Think of FT. Now, final conclusion. Now, all of you by heart this formula. This formula is very important. This is the derivation. Why we are doing all these things means we have to know the procedure first. If we know the procedure, then we can do anything. Without knowing procedure by hearting formulas, it is very difficult to solve similar questions in examination. Okay. Now see, based on this procedure, what we got finally? Fourier transform of a rectangular signal A RECT T by T is equal to AT sync FT. By heart this formula. A rectangular T by T is equal to AT sync FT in terms of sync function, in terms of sampling function. AT SA omega T by 2 in terms of sampling function, in terms of sync function. Means rectangular signal and sync signals are Fourier transformable pairs. This is another important. Initially, in the beginning, we got one statement called impulse signal and DC signal. Impulse signal and DC signals are Fourier transformable pairs. Impulse signal and DC signals are Fourier transformable pairs. Now here, rectangular signal and sync signals are Fourier transformable pairs, or rectangular signal and sampling signals are Fourier transformable pairs. Okay. Now this is one important problem in competitive examination. We may get questions on this. They will give. We will solve different questions under properties. Okay. This is the basic thing. Basic formula, that is the conversion from rectangular signal to sync signal and sync or sampling signals to rectangular signal. Okay, all of you by heart this formula. Next, determine the Fourier transform of a triangular signal. Triangular signal. How? Similar thing. Rectangular signal is this. Integration of rectangular signal is a triangular signal, or differentiation of triangular signal is nothing but a rectangular signal. This is the triangular representation. A triangular T by T. Its amplitude capital A into 1 minus 2 by capital T mod T between minus T by 2 and plus T by 2, 0. This derivation is not required actually. This is just a procedure. Use basic definition and substitute. In normal examination, we can do all these things. In competitive examination, no need to do all. This is very difficult. This is very difficult task to do all these things. We have to know the formula, like what is previous one? Rectangular signal and sync signals are Fourier transformable pairs. Similarly, triangular signal and sync square signal. Triangular signal and sync square or sampling square. Sync square or sampling square. See, if we differentiate sync square, what become? It will become 2 sampling or 2 sync. Differentiation of sine square theta, 2 sine theta into differentiation of sine theta, like that. Okay. Here also, differentiation of sampling square is sampling. Differentiation of triangular function is rectangle. Rectangle sync functions are Fourier transform pairs. Triangle sync square functions are Fourier transform pairs. We have to know this formula. Wherever appears in answers, we have to choose correct answer. A triangular T by T. AT by 2 sampling square omega T by 4 is the formula. We have to know this formula. Triangular signal and sync square or sampling square signals are Fourier transformable pairs. Now next question. Now see from here on. In examination, in competitive examination, you may get this type of questions, not this type of questions like this type of derivations, nothing. Okay, we don't want all those things. See, in examination, they will do like this simply. Determine the Fourier transform of a rectangular signal, rectangular 2T. They will do like that. For this question, No need to go for again basic definition and substitution and evaluation. Not required all those things. We have to know the formula. See, I will explain. Within 1 minute, we can finish the problem. How? See, we know rectangular signal and sync signals are Fourier transformable pairs. Fourier transformable pairs. That is, Fourier transform of a rectangular t by t is equal to at sync ft. At sync ft. We have to know that formula. At sampling omega t by 2. Where? What is the requirement? Rectangular 2t. How to get rectangular 2t here? 2t means put a is equal to 1, t is equal to capital T is equal to half. Time period, duration. Duration is 1 by 2. If it is 1 by 2, it automatically become 2t. Okay. Substitute a is equal to 1 and t is equal to half. What happens? Left side, Fourier transform of RECT 2t. Right side, see a into t. That is half sync ft, f by 2. Half sync f by 2 or half sampling, see omega into half by 2, omega by 4. That's all. Within seconds, we can finish the problem. But here thing is, we have to know rectangular signal and sync signals are Fourier transformable pairs. In options, they will give only one, like sync or sampling, though they won't represent both things. Okay, we have to know this formula. Okay, similarly, see another problem, similar problem. They're asking rectangular t by 2, small t by 2, rectangular t by 2. For such question, you have to know the rectangular signal and sync signals are Fourier transformable pairs, and we have to know the mathematical form. A rectangular t by t is equal to at sync ft. Now, required thing, rectangular t by 2. How to get? Put capital T is equal to, that's all. Capital T is equal to 2 to get RECT t by 2. And A1 not required here. A coefficient 1. A equal to 1, T equal to, substitute. Ft rectangular t by 2. Ft rectangular t by 2. That is 2 sync 2 2f, that is equal to 2 sampling omega. Such type of questions you may get in competitive examination. If you apply again Fourier transform, there will become lengthy question like this. See, this is the solution. We have to know the procedure. But in examination, without doing those steps, without writing those steps, based on final outcomes, if we know the outcome, then by substituting those things, we can easily get the answers. Okay, this is another question. See, next question. This is another important question, and once again, in examination, no need to derive all these things, not required. Gaussian pulse. This is another important pulse in communication. Gaussian pulse of the form e power minus kt square, e to the power of minus kt square, where k is positive. It is a Gaussian pulse. For this Gaussian pulse, they are asking Fourier transform. How to solve? Fourier transform of x of t is equal to integral minus equal to plus infinity. Basic definition, substitute, and not possible to do this integration in direct method. There is no direct method in mathematics, not possible. Do some calculation like it is of the form a square plus 2ab, create plus b square minus b square, like that. A square plus b square plus 2ab, compensation put minus b square, like that. Separate it and take the integration of this by go for substitution procedure. In our regular examination only, we have to do all these steps. There is no direct solution for this. But now what is our task? We are preparing for competitive examination. Gaussian pulse is one important thing. Gaussian pulse. For that, Fourier transform formula is like this. We have to know this formula. E power minus kt square. Fourier transform of e power minus kt square. For this, the root of pi by k e power minus omega square by 4k, that is equal to root of pi by k. In terms of f means substitute omega is equal to 2 pi f. Omega is equal to 2 pi f. It will become 4 pi square f square. 4 gets cancelled. Pi square f square by k. Here, if you substitute k is equal to pi, this is the formula actually. You have to know this formula. We have to know this formula. Now, if you substitute k is equal to pi, if you substitute k is equal to pi, what happens? Fourier transform of e power minus pi t square k. K is equal to pi. Pi t square is equal to e power minus pi square f square by k equal to what? Pi. K equal to pi. Pi square f square by pi. 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 1 pi cancel. Remaining pi f square. Pi f square. See this beauty. Fourier transform of e power minus pi t square is equal to e power minus pi f square. Both are same. See. Both are same. Left side minus e power minus pi t square. Right side also same thing, e power minus pi f square. Simply replace t with f. Same answers. This is the beauty of the question. Only one question. Only this question only. Frequency domain of Gaussian pulse is Gaussian pulse only. In remaining cases, Fourier transform of impulse, DC signal. Fourier transform of rectangular, pink signal. Fourier transform of rising exponential or double exponential or decaying exponential, where output is a spectrum that is symmetrical about magnitude, phase, means time domain is different, frequency domain is different. In every case, only one case is there. This is a special case. In that case, frequency domain and time domains are same. That is possible only for one special signal. Call it as Gaussian pulse. Gaussian. For Gaussian pulse only, time domain and frequency domains are same. This derivation is BTech level. This is required. Examination, we have to write all those steps. But we have to know the procedure, how to evaluate. We have to know the procedure, but in examination, without doing all those things, we need to solve those questions in a stipulated time. Okay. For that, by heart this formula, e power minus pi t square means Fourier transform of Gaussian pulse is Gaussian pulse only. E power minus pi t square is Gaussian pulse in time domain. E power minus pi f square is Gaussian pulse in frequency domain. That's all. Next. Note, Fourier transform of a Gaussian pulse is Gaussian pulse only. Next. Question number 11. Find capital G of 0 S in gate exam. It is given in gate examination. See this question. Simple question. Question is simple thing, but we have to use previous concept. What is that concept? Fourier transform of Gaussian pulse is Gaussian pulse only. That is required. Now see, find capital G of 0 such that Fourier transform of G of t is equal to G of f, where G of t is Gaussian pulse, e power minus kt square. E power minus kt square is pulse, Gaussian pulse. Okay, we know that. What we know? Fourier transform of G of t is equal to G of f is equal to Fourier transform of e power minus kt square, that is Gaussian pulse. Answer is root of pi by k e power minus pi square f square by k. This is previous derivation. Okay. If we know this formula, what they are asking, very simple thing. What is G of 0? Substitute f is equal to 0. F is equal to 0. If f is 0, what happens? G of 0 is equal to root of pi by k e to the power of 0. So here e to the power of 0 is 1. E power 0 is 1. 1 into root of pi by k. Answer is root pi by k is the answer. We can finish it within 5 to 10 seconds, but we have to know this formula. If we know the frequency domain of Gaussian pulse, then only we can finish it within 5 seconds or 10 seconds. Okay. Now, another important, again, it is also given in GATE examination. This is Gaussian pulse once again. Gaussian pulse once again. G of t is equal to e power minus kt square. They're asking, find the constant k such that d by df of g of f is equal to minus af g of f. Minus a is constant, f g. That is given such that find k value, where g of f is the Fourier transform of Gaussian pulse e power minus kt square. Okay, this is the again start with basic formula. It is known thing. Now here what is there, what is given, d by df of g of f. Now differentiate this function with respect to f. What happens? D by df of g of f is equal to, now here differentiate this function with respect to f. Root pi by k is constant. Differentiation of e power something is e power something only, same thing, into differentiation of that part, differentiation of this power, minus pi square constant, differentiation of f square 2f by k. That's all. Left side, what is there? Minus a f g of f, that is given. D by df of g of f is equal to minus a or alpha, whatever, constant, a f g of f. Left side. Right side, see, root pi by k e power minus pi square f square by k. That is frequency domain. It's called g of f. This is g of f. This part is called g of f into this part. Now see, compare these two. G of f gets cancelled. F gets cancelled. Go for cancellation. The remaining term is left hand side, minus gets cancelled. Left hand side is a. A is equal to 2 pi square by k. That's all. That is the procedure to evaluate the constant. Okay, question is somewhat difficult. This is a difficult question actually, but we have to know this formula. What is that formula? Fourier transform of Gaussian pulse is Gaussian pulse only. That Gaussian pulse is defined as e power minus kt square. For that, frequency domain is root of pi by k into e power minus pi square f square by k. That's all. That's the end of this problem. Next. See, sometimes they will give some graphical representation. Time domain signal in the form of a graph. It is also given in GATE examination. X of t is 2 amplitude between -1 and +1, and here 1 amplitude between -2 and -1, like that. Okay, for this signal they are asking frequency domain. Very simple thing, not a difficult task. Fourier transform X of, use basic definition. See, between -2 and -1, between -2 and -1, its amplitude is 1. 1 into e power minus j omega dt, plus between -1 and +1, amplitude is 2. Yes, 2 times. Between 1 and 2, amplitude is 1. Simply integrate e power something, e power j omega t. Normal thing. Just substitute upper and lower limits. Okay. Then go for simplification and convert e power j theta minus e power minus j theta is equal to 2j sin theta. It is here, I think, is minus j. E power j omega minus e power minus j omega is equal to 2j sin omega, plus again e power j theta minus e power minus j theta, 2j sin theta. Then take j common, gets cancelled. This is the remaining part. What is this actually? Sin omega by omega, sin 2 omega by omega is sampling function. This is rectangle function. Sum of rectangles. That's why we got sum of sampling functions or sinc functions. That is, this is known thing only. Rectangle signal and sinc signals are Fourier transformable space. Okay, these are the different questions given in gate examination. We can do all those things without applying properties. Without applying properties. Now the task is apply properties to solve problems. Totally 14 properties are there in Fourier transform. Apply various properties to solve frequency domain representation. Evaluate frequency. There are so many properties. Now we will see one by one. Linear property is a additivity. Normal thing. If we know two signals with Fourier transforms like this, then Fourier transform of linear combination of those two signals, that is Fourier transform of ax1 of t plus bx2 of t is equal to ax1 of omega plus bx2 of omega is called linear property of Fourier transform. Is called linear property of Fourier transform. Okay. Now derivation is not required for you. Okay, we have to know the statement. If we know two signals x1 of t and x2 of t with Fourier transforms or Fourier domains x1 of omega and x2 of omega, then the Fourier transform of the linear combination of given signals x1 of t and x2 of t is ax1 of omega plus bx2 of omega is called linear property of Fourier transform. Derivation, very simple thing, not required. Now, how to apply that property? See, determine the Fourier transform of 2 del of t minus 3 e power minus 2t u of t. From here onwards, don't use basic things. Don't use basic definition of Fourier transform. Straightforward. How? 2 del of t minus 3 e power minus 2t u of t. They are asking the frequency domain of this. Directly apply linear property. Yes, 2 into del of t. Frequency domain of 2 into del of t. 2 into del of t. Frequency domain of 3 into e power minus 2t. 3 into e power minus 2t. Fourier transform of del of t is 1. Fourier transform of e power minus 2t u of t is 1 by a plus j omega. It is of the form e power minus at u of t. Decaying exponential. I already told you we have to know some formulas. Fourier transform of del of t. Fourier transform of e power minus at u of t. Fourier transform of e power at u of minus t. Fourier transform of e power minus a modulus of t. Next, rectangular signal. Rectangular signal and sinc signals are Fourier transformable pairs. Triangular signal and sinc square signals are Fourier transformable pairs. And Gaussian signal is Fourier transform. Gaussian signal is Gaussian signal only. We have to know all those things. Okay. Simply it is 2 into 1 minus 3 into 1 by 2 plus j omega. 2 minus 3 by 2 plus j omega. Take LCM 2 plus j omega and finally get the frequency domain. A simple thing. Within 1 minute you can do it. Okay, here frequency domain is 1 plus j2 omega by 2 plus j omega. 2 plus j omega. In examination, they will give answers like in frequency complex form or sometimes magnitude form or phase form like that. Magnitude means root of real part square plus imaginary part square by real part square plus imaginary part square. 1 plus 2 omega whole square, 2 square plus omega square. That is 1 plus 4 omega square by 4 plus omega square. Similarly, phase of numerator minus phase of denominator. Phase of numerator, tan inverse of imaginary part by real part. What is imaginary part? 2 omega. 2 omega by 1 minus tan inverse of omega by 2. Omega by 2. Take the difference between these two. Tan inverse of, okay, we can leave here itself, but in options, if it is different from this answer, then we have to take formula. Tan inverse of a minus b. A minus b. Tan inverse of a minus b by 1 plus ab is the formula. A minus b by 1 plus ab. Then we can get this answer. That depends in that options. we have to choose correct answer, whether that may be directly like this tan inverse form or simplified form. We have to do it. Okay. That is the use of linear property. Linear property. Another example. See, evaluate the frequency domain of what? 3e power minus 2t u of t minus 2e power 3t u of minus t. Then repeat the procedure. Fourier transform, this is 3 is constant, 2 is constant, frequency domain of e power minus 2t u of t is 1 by 2 plus j omega. For this 1 by 3 minus j omega, this is decaying exponential, this is rising exponential. Already told you, we have to know the formulas, we have to know the frequency domain of decaying exponential as 1 by a plus j omega, rising exponential 1 by a minus j omega. That's all. 1 by a minus j omega. Now take LCM for these two. LCM for these two. The numerator, take the product, and finally get the answer as 5 times 1 minus j omega divided by 2 plus j omega into 3 minus j omega. This is simplification part. Now it is complex form. Complex form. For every complex form, we need to separate magnitude and phase. Call it as magnitude spectrum and phase spectrum. Magnitude spectrum and phase spectrum. Now, what is magnitude spectrum? See, magnitude spectrum modulus of x of omega is equal to 5 times square root of, see, modulus of 1 minus j omega, 1 square plus omega square divided by 2 plus, that is 4 plus omega square, here 9 plus omega square, 9 plus omega square. No need to take the product separation of real part, imaginary part, not required. Straightforward. If it is ratio in angle, put minus. If it is product in angle, put plus. If you want magnitude, straightforward, truncate all the terms like a plus ab. Wherever a plus ab is available, put root of a square plus b square, root of a square plus b square, like that. Okay. That's the end of magnitude, evaluation of magnitude. Then phase spectrum. Phase of x of omega. Tan inverse of, see, tan inverse of numerator minus omega by 1. Minus omega by 1. That is tan inverse of minus omega. Minus denominator. Tan inverse of omega by 2. Tan inverse of minus omega by 3. These two are in denominator, these two terms. For those two denominator terms, put minus tan inverse omega by 2 minus tan inverse minus omega by 3. Tan inverse of minus theta minus tan inverse minus last term plus. Okay, you can leave this function. Otherwise, if you want to simplify, use the formula already told you, tan inverse of a plus b, apply tan inverse of a plus b formula. That's the end of linearity. Now, time shifting property. Time shifting means if time domain signal is shifted to some other position, then what happens to frequency domain? If time domain signal is shifted to right or left, whatever, if it is shifted like this, t minus t naught, then in e power minus j omega t naught x of omega. If time domain signal is shifted to some other position, in frequency domain, take the product of original frequency and complex exponential term e power minus j omega t naught. That is the basic property of time shifting property of Fourier transform. Okay. Now apply this property to solve problems. Again, derivation not required. This is just for reference only. Now go for problem. See what they're asking. Determine the Fourier transform of a signal x of t is equal to 3 e power minus 2t u of t minus 9. Like that, they will ask question. U of t minus 9. It is shifted by 9 units. Unit step signal is shifted by 9 units. But exponential term is shifted? No. If both are, if complete signal is shifted, suppose it is x of t minus 9 is equal to what? 3 e power minus of 2 into t minus 9, it is t minus 9. Then only apply time shifting property, otherwise no. That's why first see, we know that Fourier transform of e power minus, this is of the form e power minus a t u of t. We have to use this formula and use time shifting property. Okay, if we use both the things, by using both the things, we can solve this problem. Now see, Fourier transform of 3 e power minus 2 times t minus 9, t minus 9. Reason for taking t minus 9 is, if complete signal is shifted by 9 units, then only we can use the time shifting property. 50% is shifted and 50% no shift means don't use that formula. First, create that form like x of t minus 9 like that. Okay, now Fourier transform of 3 e power minus 2 times t minus 9 is equal to, what is the formula? See, e power minus j omega t naught into x of omega. X of omega means for frequency domain, it is complex term. See, 3 is there, put 3 as it is into e to the power of minus j omega t naught. What is t naught? 9. 9 into frequency domain, 1 by a plus j omega, 1 by 2 plus j. That's all. This is the application or this property. How to use property? Time shifting property. For this left side question, this is the answer. But our question is not exactly like this. Our question is different. Okay, now minimize this one. E power minus, multiply with 2 here, minus 2t, 9 into 2, 18, e power 18, u of t minus 9. Left side, 3 e power minus 9 j 9 omega by same thing. Now, here e to the power of 18 is not required. In the question, e power 18 is not required. Okay. Now, take outside from the Fourier transform and put right side. Right side. What happens? Fourier transform. Required thing is 3 e power minus 2t u of t minus 9 is equal to right side. Here see, left side e power 18, right side becomes e power minus 18. 9 omega 18. Take 9 common here, or minus also there. Take minus 9 common. Minus 9 times 2 plus j omega. That's all. This is the answer. In multiple choice, we have to choose the correct answer. In examination, they will do such type of complicated things sometimes. Easy things you can do. Easy things, okay? If it is complicated one, then only you have to apply corresponding properties like linear property or time shifting or frequency. There are so many, around 14 properties are there. We will see the use of every property. We'll see at least one example for every property. Okay, that is one case. Now, frequency shifting property. What is frequency shifting property? If we know the frequency domain of x of t, which is x of omega, then what is time shifting? If time domain signal is shifted to some other position, in frequency domain take the product of complex exponential term and frequency. Opposite to that, if frequency domain signal is shifted to some other position, then in time domain take the product of exponential term and x of t, e power j omega naught and x of t, opposite to previous property. Now see examples. Determine the Fourier transform of e power j 4t x of t. See, x of t is multiplied with exponential term e power j 4t. Given that x of t is equal to 3 e power minus 2t u of t. Once again, we have to use, see, one is formula, that is here given question is of the form decaying exponential signal formula and Fourier transform of frequency shifting property. That is e power j omega naught t x of t. E power j omega naught t x of t is x of omega minus omega naught. See, this is known as per this formula. Fourier transform of 3 e power minus 2t u of, that is given question. Fourier transform of 3 e power minus 2t u of t 3 divided by a plus j omega. A means what? 2. 2 plus j omega. 3 by 2 plus j omega. Fourier transform of this is called x of t. This is called x of t. Now what is our requirement? E power j4t x of t. Multiply with e power j4t. If it is multiply with e power j4t, then in frequency domain what we have to consider? Omega minus omega naught. Omega minus omega naught. What is omega naught? 4. 4 means simply replace omega with omega minus 4. That's all. Omega minus omega naught. That is 4. Omega minus 4. That is 3 divided by 2 plus j times omega minus 4. That is the use of frequency shifting property, where frequency domain is shifted to some other position. In time domain, take the product of original signal and complex exponential term. Next problem. It is similar to previous question. Determine the Fourier transform of a signal e power minus 2t cos 4t. E power minus 2t cos 4t u of t. Fourier transform of e power minus 2t cos 4t u of t. Here convert cos function into like this: e power j4t plus e power minus j4t by 2, e power j theta plus e power minus j theta by 2. Now take the product like this. Now answer for this question. It is previous question, just. It is previous question. For this question, answer is 1 by 2 plus j omega. For this question, e power minus 2t u of t. E power minus 2t u of t question is 1 by 2 plus j omega, where replace omega with omega minus 4, because original signal is multiplied with complex exponential term. If time domain signal is multiplied with complex exponential term, then in frequency domain replace omega with omega minus 4 plus 1 by, here also same thing. Because of minus 4, replace with minus of minus 4, that is omega plus 4. Omega plus 4. Now take the LCM for these two terms. Take LCM. A plus b into a minus b of the form. Not a plus b into a, it is different. This is omega plus 4. This is omega minus 4. Now product 2 into 2. 2 into 2, 4. Plus 2 into j omega plus 4. 2 into j omega minus 4. Next product of these two. Okay. Take all the products and simplify it. Automatically you can get this answer. Okay, that is the use of frequency shifting property, time shifting property, where time domain signal is shifted. Frequency shifting property, where frequency domain is shifted. Opposite side, if frequency is shifted, then in time domain take the product of complex exponential term and original signal. If frequency is if time domain is shifted, then in frequency domain take the product of complex exponential term and frequency domain. Next, time reversal property. Time reversal means mirror image, folding. If time domain signal is in the form of folding, then frequency domain is also folding. Very simple property. If we know the signal, take the folding form in time domain. Automatically in frequency domain also take folding. That's all. X of minus t, frequency domain of x of minus t is equal to frequency domain time reversal form of frequency domain. Derivation not required. See the problem, how to solve, how to apply. Determine the Fourier transform of a signal x of t plus x of minus t. They are asking to evaluate Fourier transform of x of t plus x of minus t. Given x of t is equal to e power minus 3t u of t. Simply use the formula. What is this? Decaying exponential. We know that Fourier transform of e power minus at u of t is 1 by a plus j omega. A plus j omega. And use Fourier transform of x of minus t is equal to x of minus omega. This is called time reversal property of Fourier transform. Now, see, this is known thing, frequency domain of decaying exponential signal, Fourier transform of e power minus 3t u of t is 1 by 3 plus j omega. This is called x of t as per the data given. This is x of t is equal to this, and x of omega is equal to 1 by 3 plus j omega. Now what they are asking? Fourier transform of x of t plus x of minus t. Now, separate like this, Fourier transform of x of t plus Fourier transform of x of minus t. According to property, what? Fourier transform of x of t is x of omega. Fourier transform of x of minus t is x of minus omega. What is Fourier transform of x of t? That is x of omega 1 by 3 plus j omega. Substitute here. 1 by 3 plus j omega plus. Second part, x of minus omega. Put replace simply omega with minus. 1 by 3 minus j omega. Take LCM, product of these two. And numerator 6 divided by a plus b into a plus ib into a minus ib. That is 3 square minus j omega whole square. That is j omega whole square is minus omega square, minus of minus plus. 6 by 9 plus omega square. That is the use of time shifting, time reversal property. Time reversal means if time domain signal is in reverse form, automatically in frequency domain also take the reversed form, call it as folding. Folding. If time domain is in the form of folding, then in frequency domain also take the folding form. Take the folding form of frequency domain. 1 minute. Okay, that's the end of problem under time reversal property. Now, conjugation or conjugate property. Conjugation or conjugate property. Conjugate means if we know the frequency domain of a signal x of t, then the frequency domain of complex conjugate signal. Complex conjugate means x star of t. X star. In frequency domain, not simply frequency domain star, we have to consider conjugation as well as folding in frequency domain. In time domain, only conjugate. But in frequency domain, in addition to conjugate, we need to two things. One is conjugation, another one is folding. Folding is also included in this property. Okay. Now, again, derivation is not required. See this formula. See this problem given in competitive examinations. See, if x of t is real signal and Fourier transform of x of t is equal to x of omega, then what is x star of omega? How x star of omega and x of minus omega related. These two are same. X star of omega is equal to x of minus omega, and even part of the x of omega is real part of x of omega. Even part is pure real. Meaning of this statement is, if x of t is real, if x of t is real signal, then even part of x of omega is pure real, odd part of x of omega is pure imaginary. That is the outcome of this property. See how? We know that Fourier transform of x star of t is x star of minus omega. Fourier transform of x of t is equal to x star of minus omega implies x of omega is equal to x star of minus omega. That is that is a bit. A bit is very simple. The meaning of this is, if x of t is real, then x of omega and x of minus omega are complex conjugate pairs. Very clear statement, very clear and simple statement. If x of t is real signal, then x of omega and its folding form are complex conjugate pairs. That is one outcome. Second outcome, even part of x of omega is pure real, not complex, not imaginary. Similarly, odd part of x naught omega is pure imaginary. That is the outcome of this property we have shown. Next, even part of the signal can be defined as x of t plus x of minus t by 2. If you apply Fourier transform both sides, then we can get x of omega plus x of minus omega by 2. As per the analysis here, x star of minus omega means what? See, x of minus omega means x star of omega. See, x of omega plus x star of minus omega by 2. If we know x of omega like a plus ib plus a minus ib. Plus ib minus ib gets cancelled. A plus a to a by 2. A means what? Real part. This is real part of x of omega. Even part of x of omega is real. Similarly, odd signal. This is odd signal actually. This is odd signal. Apply Fourier transform. This is similar procedure. X of omega minus x star of minus omega. X of omega means what? Real part plus imaginary part. Minus of star. Real part minus imaginary part. Real gets cancelled. It will become imaginary. Odd part is imaginary. Even part is real. Even part is real function. Odd part is imaginary function when x of t is real. That is the procedure. Next, time and frequency scaling. Scaling implies signal may be compressed, signal may be expanded. Compressed form or expanded form can be obtained by using scaling property. How means? That is, if we know the frequency domain of x of t, then we can obtain the frequency domain of x of at, where what is x of at? Time scaling. If a is more than 1, signal is compressed. If a is lies between 0 and 1, signal is expanded. In time domain, if in time domain it is compressed, then in frequency domain it is expanded. Time and frequency are inversely proportional. Opposite, no. Therefore, if time domain is compressed, then it is here it is into a, then by a. If it is by a, here into a. Then 1 by mod, this is amplitude. 1 by modulus of a is nothing but amplitude. Amplitude changes. Amplitude scaled. That's why this property is called time scaling. Time domain is scaled, or frequency domain also scaled. Frequency domain also scaled, and amplitude also scaled. Amplitude scaling also. Okay, derivation not required. Now see, simple problem. It is given in GATE examination. Simple is the simple thing. Determine the Fourier transform of impulse signal. Impulse. Del of 2t minus 6. Del of 2t minus 6. See, Fourier transform of del of 2t minus 6 can be written as 2 times t minus 3. Here, take 2 common, 2 times t minus 3. It is of the form, how it looks like x of at. X of at. A. Here, A is scaled form. X of A. X of A means what? 1 by 2 is the outcome because of 2. T minus 3 is called shifting. Means it includes time shifting and time scaling. Time shifting and time scaling. Because of time scaling by 2, it will become 1 by 2. Because of it is shifting t minus 3, it will become e power minus j3 omega. That's all. It is the product of 1 by 2. 1 by 2 is the outcome of time scaling operation, just previous property, time scaling 1 by a, and e power minus j3 means it is a time domain signal is shifted by 3 units. 3 units, time domain information is shifted. Therefore, in frequency domain, it is equal to complex exponential term, that is x of that is that 1 by 2 is multiplied with complex exponential term according to time shifting property. Another one. See, it is also another question given in competitive examination gate. Determine the Fourier transform of del of 2t plus 6 plus del of 2t minus 6. Again, it includes the time scaling 2 times t and shifting 2t plus 6, 2 times t plus 3, 2 times t minus 3. It includes time shifting once again, time scaling once again. Okay, so take 2 common first, 2 common, 2 common. Because of into 2 got 1 by 2. Because of t plus 3, it is time shifting. Already told you, if time domain signal is shifted by some units in time domain, then in frequency domain, take the complex exponential term e power plus j3 omega or minus j3 omega, that depends. If it is plus 3 here, take plus 3. If it is minus 3 here, take minus 3. Minus 3. Okay, now for this outcome is 1 by 2. It is the combination here, we are applying 2 properties simultaneously. That is scaling property and shifting property. Okay, now take 1 by 2 common outside, remaining part, e power j3 omega plus e power minus j3 omega divided by 2. Now it is of the form e power j theta plus e power minus j theta by 2. E power j theta plus e power minus j theta by 2, that is cos theta, cos 3 omega, cos 3 omega. Next question. See, here the signal is x of 2t plus 3, 2t minus 3 means left shift, right shift, left shift, right shift. Scaling is included, time scaling. Next, time reversal is included, time shifting is included, time scaling is included. In this question, totally 4 operations, different operations included in the signal. What are different operations? 2t is called time scaling operation. Next, 2t plus 3 or 2t minus 3, that shows time shifting operation. Then minus 2t, minus t shows time reversal operation. Just whatever you have done in previously, repeat that procedure. Take 2 common, minus, why you have taken minus outside? Because of reversal form, time reversal. Now apply properties. What properties? 1 by 2, 1 by 2, 1 by 2, 1 by 2. Why? Because of time scaling. Next, e power j something, e power j something, e power j. Why? Shifting. If we take common 1 by 2 or x of omega by 2 outside, it will become e power j theta plus e power minus j theta by 2. Similarly, e power j theta plus e power minus j theta by 2. that is cos theta, take that part common, cos of 3 by 2 omega, then x of omega by 2 plus x of minus omega. Okay, that is the application. application of time scaling, amplitude scaling, time scaling, or frequency scaling, or amplitude scaling, or time reversal, okay, and time shifting. Okay, multiple operations are included in previous question. Now, convolution. This is one important operation in communication. Convolution in time domain leads to multiplication in frequency domain. Convolution in time domain leads to multiplication in frequency domain is called time convolution theorem. Time convolution theorem. Here, if we know two different signals, x1 of t and x2 of t, and their Fourier transforms are called x1 of omega and x2 of omega, then the frequency domain of convoluted signal, that is ft of x1 of t convolved with x2 of t is equal to x1 of omega into x2 of omega. Meaning of this is convolution in time domain. Convolution in time domain leads to simple multiplication in frequency domain. That is called time convolution theorem. This derivation not required. Similarly, convolution in frequency domain. Convolution in frequency domain leads to simple multiplication in time domain. Here we have taken convolution in frequency domain, opposite to previous statement. If we take convolution in frequency domain, that is exactly equal to normal multiplication in time domain. Okay, is called frequency convolution theorem. Frequency convolution theorem is also known as multiplication theorem. Why it is multiplication means in time domain we are taking simply the product of x1 of t and x2 of t. That's why it is multiplication theorem. It leads convolution in frequency domain is exactly equal to normal multiplication in time domain. See the application. They are asking determine the frequency domain of 2e power minus 3t u of t and 3e power minus 2t. There are two signals and there is a convolution operation between those two. They are asking what is the frequency domain of convoluted signal. What is convolution theorem? Convolution in time domain leads to ordinary multiplication in frequency domain. In frequency domain, what we are doing? Apply Fourier transform. Fourier transform of first signal, Fourier transform of second signal. Between those two, normal product. This is normal product because in frequency domain. In time domain, convolution. Now, this is decaying exponential. Fourier transform of decaying exponential is how much? 1 by 3 plus j omega. 2 times 1 by 3 times again 1 by 2 plus j omega. It is of the form e power minus at e to the power of minus at u of t. e to the power of minus at u of t. 1 by a plus j omega. 1 by a plus j omega. Simply take the product of this. 2 into 3, 6. 6 by 3 plus j omega into 2 plus j omega. How much? 3 into 2, 6. J omega into j omega minus j omega into j omega, j square omega square, that is j square is minus 1, minus omega square. Next, 2j omega plus 3j omega, j 5 omega. This is the frequency domain of the convolution of these two. Convolution in time domain leads to simple multiplication frequency domain. Next problem is, see, determine the Fourier transform of a signal x of t convolved with x of minus t. Given x of t is equal to 2e power minus 3t u of t. Again, similar question here. This is time domain representation. This it is nothing but decaying exponential signal, right side signal, because of u of t. Because of u of t right side, because of e power minus 3t decaying exponential. What they're asking? Convolution of given signal with folding form. Folding. Simply apply Fourier transform. What is this? Fourier transform or frequency domain, that is convolution in time domain, leads to simple multiplication in frequency domain. Convolution in time domain is exactly equal to multiplication frequency domain. That is Fourier transform of this is equal to Fourier transform x of t into ordinary product. Star becomes normal product. Convolution becomes normal product. Take the frequency domain of first signal, frequency domain of second. This is not star. It is not star. It is normal product. Normal product. Okay. Take the frequency domain of e power minus 3t u of t. It is 1 by 3 plus j omega. Now take the product. Here this is 1 by 3 minus j omega. 2 into 2, 4. 3 plus j omega into 3 minus j omega. 4 by 9 plus omega square. Similarly, this is last problem. Determine x1 of omega convolve with x2 of omega such that x1 of omega is equal to, this is decaying exponential, this is also decaying exponential. Here what they are asking, convolution in frequency domain they are asking. Convolution in frequency domain they are asking. Convolution in frequency domain leads to simple multiplication in time domain, and it is the formula, and it is also known as multiplication theorem, Fourier transform of x1 of t into x2 of t. Now this is our requirement actually. X1 of omega into x2 of omega imply equal to 2 pi times Fourier transform of product. This is convolution, this is normal product. Okay, take the product of these two. Normal product without doing without applying Fourier transform. You see, 2 into 3 6, e power minus 3t, e power minus 2t, e power minus 5t. Now apply Fourier transform. Fourier transform of what? This is a decaying exponential. Once again, 6 is constant, take it outside. 6 into 2, 12 pi into pi is there. Fourier transform of e power minus 5t u of t. That is 1 by a plus j omega. E power minus 8 u of t means 1 by a plus j omega. That is 12 pi by 5 plus j omega. That's the end of convolution. We have completed up to convolution. Okay, in next module, 22 pages, up to 22 pages. In next module, we will see the remaining properties of Fourier transform, and also we will see Fourier series also. We will complete Fourier series and remaining properties of Fourier transform in next class. That's the end of today's class. Thank you for patient listening, and any doubt, ask me please. Any response please?
సార్ ఒకసారి కాంజుగేట్ ప్రాపర్టీ దగ్గర ఒక స్టేట్మెంట్ చెప్పారు సార్ మీరు.
చూపిస్తాను. కాంజుగేషన్. ఓకే, ఇక్కడే కదా ప్రాబ్లమ్.
స్టేట్మెంట్ ఒకసారి చెప్పారు సార్ 20th ఆ ప్రాబ్లం లోనే ఫస్ట్ దాంట్లో. అది కాదు సార్ ప్రాబ్లం దగ్గర
ఇదే
సార్. ఆ ప్రాబ్లం లో ఫస్ట్ స్టేట్మెంట్ ఒక 3 స్టేట్మెంట్స్ చెప్పారు కదా సార్, ఒకసారి
చెప్తాను. ఇఫ్ ఎక్స్ ఆఫ్ టీ ఇస్ రియల్ సిగ్నల్, ఇఫ్ ఎక్స్ ఆఫ్ టీ ఇస్ రియల్, then the frequency domain, that is x of omega and x of minus omega, are complex conjugate pairs. Means original frequency domain and folding form are complex conjugate pairs. Ela ante manamu we know that this is known thing. Fourier transform of x star of t is equal to x star of minus omega. This is the property. According to this property, if x of t is real, if it is real, if x of t is real, then x star of t is equal to x of t only. Simply x of t. Fourier transform of x of t means what? X of omega. This is x of omega. This is x star of minus omega. X of omega is equal to x star of minus omega. We can put complex conjugate left side or right side. Both are same. We can put left side x star. It will become x star of x star. Same thing. That is x star of omega is equal to x star of minus omega. Meaning of this is x of omega and its folding form x of minus omega are complex conjugate pairs. This is original property. Part A is nothing but conjugate property. Part B is nothing but this is given in some problem in gate examination. Like sometimes they will give x of t. X of t is original signal. Any signal can be represented as the sum of even part and odd part. Any signal x of t Any signal like x of t can be written as xe of t plus x naught of t. Any signal can be written as even part plus odd part, even part plus odd part. Now the frequency domain of xc of t is nothing but capital Xc of omega. Similarly, Fourier transform of x naught of t is nothing but x naught of omega. Fourier transform of xc of t is xc of omega, and Fourier transform of x naught of t is nothing but x naught of omega. Here what they are telling, even part of the signal is always real. In general, frequency domains are in complex form. Complex means that consists of both real part and imaginary part. But even part of the signal, even part of the signal is always real. Odd part of the signal is always imaginary. నీకు ఇంకా దీనికంటే కూడా నేను ఆల్రెడీ ఫస్ట్ మీకు చెప్పేసాను చూడు. అక్కడికి వెళ్ళిపోదాం. అక్కడ మీకు చాలా క్లారిటీ వచ్చేస్తుంది ఇంకా. See this problem. Here x of t is real or complex or imaginary? The signal. Babu, వింటున్నావా?
sir.
This is real signal?
Sir.
Yes, exact. This is real signal. Now coming to frequency domain. Frequency domain. How much? 1 by a plus j omega. 1 by a plus j omega. ఇక్కడ మనం ఏం చేసామంటే మ్యాగ్నిట్యూడ్ చేసాం. ఇక్కడ మ్యాగ్నిట్యూడ్ ఈజ్ రియల్, సారీ మ్యాగ్నిట్యూడ్ ఈజ్ ఈవెన్, దెన్ ఫేస్ ఈజ్ ఆడ్. ఇది ఈవెన్, దిస్ ఈజ్ ఆడ్. ఇదే విధంగా వాళ్ళు ఏం చెప్తున్నారంటే అక్కడ స్టేట్మెంట్లో ఇది కాంప్లెక్స్ కదా, దీన్ని సపరేట్ చేయి. ఈవెన్ పార్ట్ అండ్ ఆడ్ పార్ట్. ఈవెన్ పార్ట్ ఈజ్ ప్యూర్ రియల్, ఆడ్ పార్ట్. ఈవెన్ పార్ట్ అంటే ఏంటిది? ఎక్స్ ఆఫ్ మైనస్ ఒమేగా ఎవాల్యూట్ చేయండి. అంటే ఒక ఎగ్జాంపుల్ తీసుకుంటే మీకు క్లియర్గా అర్థమవుతుంది. ఓకే, ఈవెన్ పార్ట్ ఈస్ ఆల్వేస్ రియల్ ఫంక్షన్ అండ్ ఇమాజినరీ పార్ట్ ఈస్ ఆల్వేస్ ఆడ్ ఫంక్షన్. దట్ ఈస్ ది అవుట్కమ్ ఆఫ్ కాంజుగేషన్ ఆర్ కాంజుగేట్ ప్రాపర్టీ. ఇంకా బాబు ఇంకేమైనా ఉన్నాయా? హలో,
లేవు సార్. ఓకే సార్,
గుడ్. మీకు ఏదైనా డౌట్స్ ఉంటే బాబు మేడం దగ్గర ఫోన్ నంబర్ తీసుకోండి. మీకు ఏదైనా ఉంటే వాట్సాప్లో నాకు ఏమైనా మీరు ఎనీథింగ్ మీరు పోస్ట్ చేస్తే ఐ విల్ గివ్ ది సొల్యూషన్ అండ్ ఐ విల్ గివ్ ది హింట్స్. ఓకే, థ్యాంక్ యూ బాబు, థ్యాంక్ యూ. మేడం ఆర్ యూ దేర్? ఓకే బాబు, గుడ్.